Okay, so we are going to look at force analysis with motion practice problem number 4. And it reads, a 1580 kilogram car is traveling with a speed of 15 meters per second. What is the magnitude of the horizontal net force, so the total net force horizontally, that is required to bring the car to a halt in 7 seconds? So we're interested in force, what the force is. That's a force analysis. So we're going to start with our object. And we're looking at the car, what brings it to a halt. So our car is the object, so we'll draw a little car on there. And now we have to look at the interactions. So what's interacting with this car? Well, we have the force of gravity. That's between the car and the earth. And as we develop our interactions, we can develop the free body diagram. So the force of gravity, gravity always acts down. So we have our force of gravity, which to keep in mind is mg, which also goes by the weight. All right, what else is the car interacting with? Well, it's interacting with the road. It's sitting on the road, squishing the road's molecules, so the road is pushing back, and we call that a normal force. So between the car and the ground, again, it's pushing back as the car sits on it, so our normal force will be pointing up. Now, I've drawn these two arrows together thinking about, well, if there's anything else vertically happening, I might have to make an adjustment, but I don't think so. I don't think there's anything going on, additional forces happening vertically. The car is certainly not changing its motion up and down, and so those two arrows, in my prediction, should be the same length. All right, so anything else? Well, we know that the car is coming to a stop, and so we want to look at it asks us to look at the net force that brings it to a stop. So we'll call that the force of stopping. It's going to be everything that's included in that process. So we have the car and then all things stopping, to stop. Together, we're looking at it as a collection. Well, if the car is heading to the right, and we have to define that motion, so we'll say the car is heading in that direction. It's slowing down. It's coming to a stop. It's heading to the right and slowing down. The acceleration is to the left. And so our force causing that acceleration, our stopping force here, is going to be to the left. Now other interactions, I think that does it for our free body diagram. So we're interested in what is that stopping force. So we continue our analysis, numbering each one of our forces, and then analyzing their horizontal and vertical motions. So force 1, nothing horizontally, only vertically. It's acting down, so we have a minus Fg. Force number 2, nothing horizontally, only acting vertically in the upward direction, a positive N. And our stopping force is acting to the left and nothing vertically. So now we can apply Newton's second law. Newton's second law tells us that the sum of the forces horizontally are equal to the mass times the acceleration horizontally, and the sum of the forces vertically, the mass times the acceleration vertically. We can separate that analysis because motion is independent, and therefore what causes or changes that motion must also be independent. I'm interested in the stopping force, so I'm going to start with that horizontal list. That's where my interests lie. 0, 0, those add up to nothing. So we have minus the force of the stop equals the mass times the acceleration in the horizontal direction. And I want this force stop by itself, so I'm going to take that negative to the other side. So minus the force of the stop equals minus the mass times the acceleration horizontally. I'm given the mass as 1580, but I don't know that horizontal acceleration. I need acceleration horizontal. Well, we learned a whole way to describe motion. Acceleration is one of those descriptors. Let's look to kinematics to see if we can figure it out. After all, it's the forces that cause that kinematics. So, kinematics requires us to identify an object, have it identify the world. So let's put on an origin in our picture, and then we can start our process. Initially, we're interested in when we start the force. So when the force begins the slowing down. And final, well, that's when it comes to a stop, or at 7 seconds. We're told it comes to a stop in 7 seconds. So both of those describe when we're stopped caring about the motion. Okay, looking at our list, positions, initial and final velocity, acceleration, and time. So where does the car start? The car start when the force starts. That's at 0. We don't know where it ends. Our initial velocity when we start applying that retarding force is at 15 meters per second, slowing that force down. We then want to know our final velocity when the car comes to a stop. Well, that's 0 meters per second. We don't know the acceleration, but we do know that it happens in 7 seconds. Now, why did we go to this kinematics process in the first place? What's our variable of interest? We needed acceleration, remember. That was our variable we wanted. So, we're going to go after the acceleration. Both equations in kinematics have acceleration. Which one are we going to use? Well, we know more information about velocity, so let's start with that one and see if it gets us what we need. V final, 0. V initial is 15 plus an acceleration, of course we don't know, times our 7 seconds. So we can solve for acceleration. Minus 15 equals 7a. A then equals 2.14 meters per second squared. All right, now I have my acceleration. I can plug that back into my relationship for the force. I get minus 1580 times minus, I dropped my negative there, so this should be a minus 2.14 is going to give me a stopping force, the strength of that force, as 3,386 newtons. So the size of that force is 3,386 newtons. We know, of course, it's pointing to the left. All right, so force analysis. We wanted a force. We needed acceleration. That lets us look at kinematics, the descriptors of that motion. Once we look at our kinematics, we were able to obtain that acceleration. It made sense. It was negative. We know that if a car is moving to the right and slowing down, the acceleration has to be negative, and the force that's causing that acceleration, of course, is what we're after. Good job.